I would like to introduce Rich Mogull with Securosis. And friendly reminder, everybody, please, at the close of the talk when you leave the room, please scan your cards so that we can send you a survey. And with that said, I'd like to introduce Rich.
Thank you. First of all, I really would like to thank everybody for showing up this morning. I am very likely going to regret that, since I got less than 90 minutes notice that I was going to be giving this talk today. So for those of you who are expecting, I don't know, some exploitation talk, this is not it. You can leave now. I'm not personally offended. And instead, we're going to take a little bit of a defensive take today. Now, if you can tell from my voice, I wasn't planning on giving a talk this morning. And I might have been out a little late last night. And when you're given 90 minutes notice to put together your very first technical talk at Black Hat, I've done non-technical things before, you cram a little, I change my underwear, those sorts of things happen. So if you're nice to me, I'll be nice to you, and we'll all get through this okay. So I've got some good news and some bad news. The good news is I actually have a working technical demonstration. And it's actually probably a good chunk of this session. We'll be going through how that works. The bad news is I may have cobbled together a few of the slides last minute. So again, be a little kind when you do the evals on that part. 90 minutes notice, right when I woke up. So I've been covering cloud computing for a while. And aside from just speaking at conferences and working with clients and those sorts of things, one of the things that I've been doing is spending a lot of time out there teaching people cloud security. So we built the training program, my company, for the Cloud Security Alliance, and we did trainings here at Black Hats and places like Black Hat Abu Dhabi, which is really great. And the more time I spend working with people and teaching cloud and getting hands-on and kind of digging in, the more I'm kind of becoming a little bit obsessed. Cloud is, I think, fundamentally going to change security in ways that we're barely conceiving of today. And a lot of it's for the reasons that I'm going to talk about and probably reasons that I don't even know about. So the structure of this session is going to be, I'm going to spend about 10 or 15 minutes giving you guys a little bit of background. One thing I've learned as I've been going around there talking with people is not everybody thinks of the cloud the same way. Not everybody focuses things the same way. So I've got to do a little bit of setup on that. Then I'm going to spend a few minutes talking about some of the security advantages I think cloud provides. A lot of people like to think cloud is less secure. To me, cloud is no more or less secure. It's just different. And I'm actually starting to think in some cases, it really can be a lot more secure. And so this is going to be a bit of a rah-rah session as I try and show you why I think cloud is going to be more secure in a lot of ways and the tremendous benefits that it provides us as security professionals, giving us capabilities we've just never had before. And most of it comes down to this concept of software-defined security that we're going to get into. And then after I get through all of that stuff, maybe 15, 20 minutes tops, hopefully, depending on if you guys have questions, we'll spend most of the rest of the session. I'll actually show you how to do some of this hands-on yourselves. And unlike some of the technical demonstrations you see here at Black Hat, in some ways this is pretty basic. It's the kind of thing that you can actually do yourself at home on your own Amazon accounts. I have all of the scripts published, all of the code published. You can email me if you have questions. This is the kind of stuff I want people to do. There's no secrets here. It's how it works, and it's how people are actually doing this in the real world. So the concept of software-defined security in the context that we're going to be talking about today is the idea that security doesn't, or cloud and automation don't just bring risk, it actually provides us with a lot of benefits. And it does this because we're actually able to decouple security from the underlying infrastructure, and everything all of a sudden becomes managed by APIs and software. And in a sense, as security professionals, we're going to become, if you think about our history is as cryptographers and as network jockeys, but that's going to change. And we're going to be more around, shall we say, elegant programmers and coding and learning how to integrate those things in our environment. And a lot of this is coming down to being able to take the skills of the DevOps community, who in many ways is ahead of us in terms of their leverage and their adoption of these technologies. And we're going to take the lessons that we can learn from that community and apply it to security. And it builds us far more dynamic, automated, and responsive security programs. In some cases, we get things security by default, particularly in cloud, that once I realized you could do this stuff, just my eyes pretty much exploded out of my head. Almost like the stuff in my pants when I got the call to do the talk this morning. So let's spend a little bit of time, and again, I don't want to go too in depth in this. How many people have actually launched stuff on Amazon or Rackspace or anything else? All right, so I can go through this pretty quickly. You guys have a background on this. It's just a little bit, everything I'm going to do right now is focus on infrastructure as a service. Some of it could be applied to platform as a service, but we're going to just kind of keep it simple and focused. And then when it comes to defining the cloud, the model that we like to use at the Cloud Security Alliance, I like to use is the NIST model. I'm not going to go through all of this, but the key piece are these essential characteristics. These are the things that every cloud has. And if we look at the pieces that every cloud has, a couple of them have really significant consequences for those of us in security. The primary being broad network access. The thing about cloud is everything you do on the cloud has to be manageable over the network. Now let's take a step back and think about how do we do most of our security today. The vast majority of security today is we've got our infrastructure, and then we start layering boxes around our infrastructure and layering things within our infrastructure. And we have boxes talking to boxes over wires, and we put more boxes between the boxes, talking to the boxes on the wires, and that's basically how we build our security program. And it's a fucking disaster. Because if you put the box between the wrong wires and the wires into the wrong box and somebody goes click, all your security gets screwed up. It's a very manual process. The reason for that is as security professionals, it's like we're trying to protect everything from the outside. We're not in the game. We're not actually embedded in the infrastructure ourselves in many cases. And it's not always true. Some of you work in really cool places where you get to do that stuff. But when you get into cloud and you get into the fact that not only the security but the infrastructure itself is managed over the network and managed over APIs. The same tools that the people to manage the infrastructure use are the ones that we in security use. And it really, again, is one of the reasons that we can get a lot of these benefits. And the key to gluing all of that together is two pieces. One is this concept of resource pools. So this is what powers all of the cloud. You take a bunch of your stuff, you add a thin virtualization layer on top of it, you add an orchestration layer on top of it to handle all of the communications, and then you pull things in and out of the resource pool as you need them, configure them as you need them, using highly automated and orchestrated processes. So that's getting us to a couple of key points here. Everything is managed over the network, everything is automated and orchestrated, and again, APIs is the tool that we use to do a lot of that, plus virtualization. So a quick primer on how actually infrastructure as a service itself works. To give you an example of this, if I want to launch an instance in something, I set an API call. Remember, use API calls, not the web interface, because we're cool hackers at Black Hat. If you use the web interface to like manage your Amazon, you're a total freaking loser, and people won't like you anymore. Admittedly, I'm doing my demo through the web interface, but I'm a total freaking loser and nobody liked me ever anyway. So that's okay. I've come to terms with it. I go to therapy. So you come in, you make your IPA. Everybody knows what I did last night. You make your API call, comes into your cloud controller, and your cloud controller goes, hey, I've got all these boxes with hypervisors on it. I didn't know where there's space. So, oh, I have space over here because I've got like this whole database and I know everything that's in my environment because I am the master controller. So I've got space over here. I'm going to take my operating system over here out of storage, which is the image service storage. I'm going to stream it over here. I'm going to make, hey, let's do a terabyte virtual hard drive. I'm going to plug that in. And all of those managements and all of those controls are going to be happening over those APIs. Really straightforward process. Those of you who launch instances, that's how it works. Put the request in, find space. Now, when you send a request in to a public cloud provider like Amazon, do you know what server you're on? No, not all. Do you, when you're in racks, when you're using something like OpenStack, do you know what server you end up on? It depends. If you're the consumer of the service, no. If you're the cloud master on top, yeah, you can actually see and manage that stuff. And so one of the security things we do is we can actually do all sorts of dynamic filtering and things such as, hey, if the accounting department ever launches an instance, it goes into a PCI zone, which is a specific set of physical hardware. Now, that is not all out of the box today, but that's stuff that you can program in as a security professional. Why would you do that, by the way? Why would you want all your PCI stuff to show up in one rack? What? Limit your scope for your PCI audits. Yeah, exactly. Otherwise, every virtual machine in your cloud is within scope of your PCI audits. So again, that's just a very simple example of using automation to route things to physical places to deal with well, okay, it's not security, it's It's kind of more like a racketeering scheme, but we're still stuck with it for compliance reasons anyway. So that's enough of that little bit of primer stuff. Let's start talking about where some of these security advantages come from. Because we have these APIs and because we have all of these capabilities, we start having the ability to go ahead and automate our security to a degree that we haven't been able to do before. That's what most of the demo I'm going to do today is all about. Who here knows what KickaaS Monkey is? The Netflix guys talk all the time. Yeah, KickaaS Monkey is freaking wild, okay? And they've published a bunch of this. Amazon, when their developers build things, they build things knowing that they will be destroyed. KickaaS Monkey is a script that runs around their environment and just shuts off virtual machines, shuts down instances. Oh, let's go ahead and terminate these instances. Let's take out an entire availability zone and see if my kids can still watch Mickey Mouse. And they do that because that forces a resiliency upon their developers because they have to develop knowing things will go down. Do we get to do that normally in our traditional infrastructure? No. Like, I'm pretty sure if any of you walked into the data center and go, I'm going to see how the developers are doing today. Click, 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 click. You might end up getting to meet Eric Snowden, all comfy and personal, in pajamas. So, they also have tools, one called Security Monkey, which they haven't talked a lot about, but supposedly it validates security group rules and firewall rules and digital certificates and does a bunch of security automation. And today I'm going to premiere something called Security Squirrel because I don't want to violate their copyrights because they're bigger than me, which is just a very, very, very simple proof of concept to show the beginnings of what you could potentially do here. And we can do this because we've decoupled security management from the infrastructure while also being embedded in the infrastructure. We're not relying on the boxes and wires anymore. We're not relying on having to install manually extra software into systems so that we can control things. We're not putting all of these perimeter and gateway pieces in place. Everything we do, now we can directly manage that infrastructure ourselves and integrate that into our security tools. So let me give you an example, and again, this is where the slides get rough because I'm probably getting ahead of myself. If you have a vulnerability assessment tool that has APIs enabled, and by the way, very few security tools have APIs these days. Some of the vulnerability assessment ones do. I know Tenable does, Qualys does, for example. I'm sure there's some of the other ones out there. But if you have those APIs enabled, you can do pretty wild things like anytime somebody launches a new system in your environment, your cloud environment, the cloud controller will automatically open up a port for only your vulnerability assessment tool, will pre-send it things like the operating system and other metadata, and I'm going to show you what some of that metadata looks like a little bit later today, because we have it. Then that tool can automatically do the assessment of your instance, and if it passes your assessment checks, then it will shut down the firewall rule that was connecting it to your security tool, and then it will open it up to the rest of your environment, and that system can function normally. And then you can do ongoing assessments, just opening up those holes as you need to for your security tool to be able to do that evaluation. That's the kind of thing you can do once we start automating security. Another example of this is one of the things I'm probably going to get programmed up next after this demo is I thought it'd be really cool to have a red alert button on my iPhone. And that red alert button will be that if I detect an instance that I'm worried about it, I click red alert for incident response. And what would the incident response script do by plugging into these APIs? Well, it's very, very easy for me to do the following things. One, I would instantly snapshot that instance, which is basically recording all the hard drive, save it off someplace securely that only security can access for my forensic analysis. That'd be the first step. Step two in this little script that I'm planning on putting together would be I would shut down all the inbound and outbound ports onto that system, and only that system. I can do that instantly without touching a regular firewall. I just handle it all within the security groups that are in there. Number three is I can reassign the management rights of that to the security team. So all of a sudden I can lock out all of the developers, I can lock out all of the administrators, and I can reassign the Amazon rights, or your cloud, whatever cloud platform you're on, rights to the security team so that they are the only ones that can now do anything with that instance in the cloud management plane that's managing that infrastructure. Then I can actually open up ports to the security SOC so we can do analysis. If you want to get really fancy and you're worried like cool APT stuff and command and control and everything else, you could do some of that, but you could actually reroute all of your network traffic through, say, a proxy and start sniffing that traffic and block the bad traffic. To do that, as I just described, I'm estimating is about 40 lines of code. All of the pieces I described. Because you'll see the stuff I did today, the script is it is 40 lines of code or 41 lines of code. About 15 of that is just setting my security credentials, and then like another 10 to 15 of commenting, so everybody knows what I did. And then the rest is the logic, and that's like less than 10 lines of code to do this. So we have full control over the fundamental infrastructure that we are in. We can move virtual machines around, we can control the network characteristics of those machines. With some of the additional things I'm going to show you, I have full control of the host level stuff. We can do instantaneous snapshot backups. We can't do that with traditional infrastructure, none of it. And there's some other cool advantages. The fact that if you're spinning up an instance, and this is, remember, your mileage may vary. Your cloud may vary. So a lot of what I'm talking about is kind of Amazon-centric. I don't work for them. They've never paid me money. I pay them a lot of money for 2-day shipping, which is awesome. And when they have groceries in Phoenix, like it's all over. I'm never leaving the frickin' house anymore. My wife and I order toilet paper and paper towels on Amazon. That's the other part, not the web services. The EC2 team would be really confused. So when you're running things in this environment, if you spin up instances, one of the wild things, for example, with Amazon is every single thing that you spin up in either public cloud, in the public cloud side of EC2 or VPC, every single server has a software firewall surrounding it. Now it's really basic. It's not advanced. It does do inbound or outbound, but it's not a stateful packet inspection firewall. So like if you want to do your outbound controls, it's ugly because you have to manually figure out all of the port ranges for the response traffic. So for you non-network people, you get an inbound port 80 call. If you're running a web server and when you reply, it can reply over thousands of ports. And you have to put in rules for thousands of ports to go outbound, as opposed to a stateful packet inspection firewall, which just figures out those session return traffic. So everything is segregated by default. But here's the cool thing that a lot of people don't realize. So security groups. Is a security group kind of like a subnet behind a firewall? When you set a rule, that rule applies to everything behind it, but those things can talk to each other. Who says yes? They can talk to each other. I know, it's kind of a setup question. Can somebody raise their hand so I can mock you anyway, just out of sympathy? You! Yes, thank you for being stupid. So, when you use a security group, and this actually confuses a lot of students and stuff when I'm teaching it, every instance launches in its own isolated area, and it can't even talk to other things in the security group unless you create a rule to do that. How hard is it to put a per system firewall on everything you have in your environment right now without installing any client software in that operating system? Who says impossible? Nobody? It's really hard. I don't know anybody who's doing that. You can manage IP tables, you can set your Windows firewall here by default. Everything is segregated out from everything else. And it's all managed externally from a security plane. Why is that really cool? Because if you get host level security without having to manage host level firewalls and credentials. The security team can manage everything from the outside. That's just a really basic example. So we have dynamic automated software defined firewalls built in. And with those, there's no sniffing on this network. Because with one checkbox or by default, you actually, I know, last minute slides. I only have a couple of funny ones in there. By default, you turn off sniffing in your virtual network snack. Wow! That's what you get for going out. So, I'm normally more professional. I don't drink the night before things like this, if I know I'm doing them. So, you have basically, VMware, you can turn it on if you want an admin thing to be able to actually sniff your network. But any of the cloud platforms, promiscuous network sniffing is disabled by default. So you have no sniffing, you have everything segregated. That's just how the cloud works. It's the built-in segregation and isolation. And this is getting even more interesting now that software-defined networking is starting to pull in. For those who don't know, for example, OpenStack is going to be SDN only as their platform. They're actually getting rid of their VLAN, DHCP-based networking model and going completely to a software-defined networking model with GRE tunnels and other things connecting all of the pieces together. Now, that's great. That's what you get automatically with the cloud, but what you don't get is a lot of your host security. And you really do need to actually take some extra steps for that. And I'm going to actually show you some examples because when you spin up instances, because everything relies on automation and pre-built images, you can actually inject a lot of capabilities in a dynamic way into the virtual machines that you're launching. So if you think about a traditional VMware virtual machine, you start it up, you start from a base operating system or one that's pre-configured, and then you have to manually go in and do stuff. We're going to show full automation in terms of how to do that, and that's part of the demo that we're going to do today. And we even get advantages through things like greater adoption of identity management. For if you're using Salesforce and you integrate it into SAML within your organization, there's really cool stuff because how federated identity works, where the only way your user can log into the cloud is if they are physically logged into your network or over a VPN. So they log into the network, they get their federation token, then they go to Salesforce to log in. They never actually have a username or password to log into there. So that's why there's like a lot of these cloud identity providers that are starting to pop up. For software as a service in particular, not just for Salesforce, but they have all of these services. Do you want to manage all of your users across all of those? No, it's a nightmare. I mean, we don't want to create individual user accounts in all of those services. So, by pulling in something like federated identity, we can actually just set it up in Active Directory. We can have a broker proxy either in our environment, or you can actually host that up in the cloud, and all the users have to log on to our network before they can actually gain access to all of these cloud-based resources. They don't even have access credentials up there. So they have the policy, decision point is here and the enforcement point is up there for you identity management geeks. And lastly, and I think in many ways one of the most important things, is there's no Neo in the cloud. Everything I described when I was setting up a bunch of those architectural pieces, it comes down to the fact that you have a controller that fully manages your environment. Your cloud controller knows what's in every virtual machine running on every server. Your cloud controller knows the network configuration of everything. Your cloud controller knows where all of your storage is, where everything is in that environment. Now on our network, somebody can hop on, they launch a virtual machine, we don't know where it is, we don't know what it's doing, it can hide behind our security. That's one of the most common ways to get in there and do things. With the cloud, knowing what's in my environment is a single API call, or a command line call. It's, let me see if I can pop it out real quick. I have a cut and paste here to demo it. And again, this is remediary for some of you that have done this stuff before. This isn't even part of my formal demo. Yeah, that window's got to close anyway. All right. What I'm doing is I've just got notes. Can never remember where I keep my configuration file for the Amazon command line. All right. Oops. And we get to see how fast the network is. So I keep my credentials in an encrypted storage space, and I wasn't logged into it. Nobody remember my password. It's 1234, the same as your luggage. And then I do this. Come on, give me a little credit. Yeah. I didn't actually expose it, I don't think. It will be? All right, I'll have to change it. I didn't actually show the password for this, but another one got exposed. That's cloud encryption, if you were wondering about it. It's a beta that SafeNet is running that I've been playing with. All right. All right, I won't play with this much longer if it's not going to be nice to me. I'll set the environment variables. All right, let's go back to the slides. I'll try and pop that out at the end. As that thing is mounting is the problem. So what I was going to say is if you hit that command describe instances, it shows you everything running in your environment. Not only does it show you everything running in your environment, it gives you a tremendous amount of metadata about it. Down to the hypervisor that's running, to the operating system that's running, the full network configuration, all the IP addresses, everything. With just that one command line call plus the API calls. You can't hide in the cloud. You can't have anything running in your cloud without you knowing where it is. Because if you don't know where it is, the cloud controller doesn't know where it is, and the cloud controller doesn't know where it is, it doesn't exist. So Neo's fucked. There's no Agent Smith going after him. With a keystroke, you find out where he is, and you can decide to get rid of him if you want. So let's talk about the software-defined security concepts itself. And this is where we're going to be using things like APIs, glue code, automation and orchestration, and even immutable servers for security purposes as opposed to the DevOps guys. So your DevOps guys are doing all sorts of crazy stuff with Amazon, auto-scaling stuff in, auto-scaling out, dynamically configuring, managing tens of thousands of systems with simple scripts and everything else. There's no reason we can't do that for security. And as a matter of fact, most of them are doing a lot of security in their environments, and you may not even know what that is. So now I'm going to get into the demo and show you how to use some of this. So this is like DevOps 101 stuff, but for most security professionals, we've never seen this. So I'm going to show you how to automate cloud security and appliance. We're going to leverage Amazon S3, EC2, and APIs to bootstrap some security policies into some initially running instances. Then I'm going to show you a software-defined security application, which is where I'm using just a couple of APIs to actually go ahead and do some management in our environment. And I've got the slides to show this. I'll just blast through it really quick. So what we're going to do is, one of the interesting things that Amazon added is something known as IAM roles. Anybody know what these are? Have you used them? They're relatively new. Yeah, they're really cool. So an IAM role, think about how we normally set security credentials for something in the cloud. You put an access key and a secret key into whatever application you need access to, and that's the API access. Now, you can build your applications so they can do really cool stuff accessing the Amazon API. But once you put your keys in there, what do you have? What do we yell at our developers about all the time for? Exposing the keys on the servers. Anytime we put credentials into systems, we're always yelling at developers, don't put passwords in, don't put keys in, don't put certificates where they can be exposed. Now think about the cloud, where with one button I can click a snapshot and I can pull all of that out, snapshot it, and make it public. I had some attack code I used 2 years ago at a DEF CON presentation, which would do that. Snapshotted every single volume in your environment, and then made all of those volumes public. And it put DEF CON hacked me as the tag, so I could find them very, very easily. And all of that ran in user land if I got onto an admin system. So IAM roles are awesome. Amazon came out, they said, you know what, we got a way to solve this problem. We're going to take the problem of static security credentials off your hands. You can assign an IAM role to any object within Amazon. Or, well, not any object, but particular objects, like your running instances. And when you assign that role to an instance, it gives it three pieces. It gives it the access key and the secret key, the normal stuff we have for our REST API, and it also gives it a token. And the tokens are rotated, about every 24 hours, I think, I've noticed? Every 4 to 6 hours these days? Yeah. So it's every 4 to 6 hours, it rotates those credentials. It rotates the token. That means, and those credentials aren't actually stored in your server unless you write code to store it in the server. So what that means is if you enable that role, and then within Amazon you can say, you know what, anything with this role can access my Amazon S3. We have temporary security credentials. Those credentials are automatically rotated for us by Amazon. It's handled without us putting any code into our system. And we can use that to manage other connections to other aspects of our cloud infrastructure. So we'll show you a little bit of the basics of how that works. And what I did is, what I'm about to show you in the demo, and again, I consider this pretty basic stuff, so hopefully you won't be offended. But we have a running Amazon instance that's set up over here, and we installed something called S3 tools, which just gives you access to something in an Amazon S3 bucket. So that's the command line tool so that I can script access to that bucket. Then I have a secure Amazon S3 bucket. This bucket is only accessible by me, the cloud administrator, as well as anything with the proper IAM role. And so S3 tools, using the temporary security credentials, is going to go to the bucket and it's going to pull out my Chef credentials, which I need to use to initially bootstrap this instance into a Chef configuration management environment. Now, what's interesting about Chef is if you've ever set Chef up, Chef by default actually also uses temporary credentials. So this validator certificate and this client file, that digital certificate only allows one action, and that action is to allow something to become a Chef client as part of a new node in your Chef management infrastructure. And then that certificate is not usable for anything else within the Chef environment. So that's a way that Chef uses to allow something to say, hey, I want to be managed by you. Come on, take me over, baby. And sends the future credentials down to kind of link it up into that environment. without creating any additional security risk. So I have an Amazon S3 bucket already set up with the policies that you can't read because the slides, the projector's kind of cruddy, which basically says only I can access it. And what I've done is I've put these security credentials into that bucket. So let's go ahead and actually start showing you how this stuff works. Am I doing okay for 90 minutes notice? All right, so I'm not going to show you the S3 piece. Just trust me, I have secure credentials stored up in there and the proper policy set to it. Now, what I'm going to do is I'm going to run my instance and launch some instances here. When you launch an instance, you'll see there's the user data field, which is where you can inject scripts. So this is a script that I put together that basically is designed to bootstrap these instances into Chef, and it does a couple of things. So the first thing is I actually have to install Chef, and that's what all of these pieces do. So they actually are just going ahead and installing Chef, pulling down the information that you need, and you know what? I almost found a bug in my demo code here that I'm about to go fix. And sets all the initial variables and stuff for it. So the next thing we need to do is use these S3 tools. Now, when you're using something that uses IAM roles within Amazon, that tool has to be programmed to understand IAM roles. What it's doing is it's making calls to the metastructure within Amazon to pull down those credentials and use them temporarily for the future access. And so it turns out that for those of you who actually try and do this, if you're using S3 CMD, which is the command line tools, you have to use an alpha version which supports this, and then you have to create a dummy configuration file, otherwise it all breaks. None of that was documented, of course, which led to a very annoying weekend. So then we go ahead and we pull down all of those security credentials, and then we run Chef for the first time, and then we actually embed another little piece onto it, which is setting a role. So the first time I'm running Chef, I'm actually setting it as a role known as a base role. We'll talk about Chef stuff in a little bit and how that works. But what that does is that will set the role for it, and then I have a whole set of policies that apply to that base role. For you guys on the security side of the house, your DevOps, your admins have base roles guaranteed, and that's the base set of stuff they want to run on everything in your environment. And those can be really complex. They can account for different operating systems. They can account for different environments. What you want to do is that's where you hook in your initial security policies for things that you actually want to run within an instance. And this works for traditional infrastructure too. It's just this is a cloud talk, so I'm only talking about cloud things. All right, so I have to pull my Chef server address. I have like 4 versions of this script, and so I think that the one I just pulled up on the screen, which I'm going to have to paste in, actually didn't have the right IP address on it. So all right, should I make the text bigger? Can you see it at all? All right. So put in the server address here for my Chef server. Yep, that's correct. All right, let's go launch some instances. Oh, before I do that, this is my existing Chef server right now that's out there running in my environment. You can see I've got 2 instances that are managed by Chef. I'll show you a little bit about what's that. These are basically Chef nodes. And oops, wrong Windows here. Let's go ahead and launch like 10 more. So let's go 10 to A. We paste in our initialization script. So what happens is these cloud init scripts is the name of this. These run as root in an instance when you boot it. The operating system has to support it. It came out of Ubuntu originally. A bunch of the major Linux stuff supports it. And then here's the important trick, which is you have to pick the right IAM role. And in this case, it's Chef client. So this is now going to run this script as root in all of these instances. Put it in the right security group, otherwise I can't talk to things. All right, so I now have 10 servers launching in my environment. as you can see here. I'm going to go back to the slides a little bit because it takes time for these things to run and to run the initialization scripts. And the Ubuntu demo stuff I'm doing here can take about 10 minutes, between 3 to 10 minutes, depending on exactly what's going on. All right. So while all that stuff's running in the background, we've gone ahead. That's actually how you create a role. And roles are pretty interesting in terms of how you actually go ahead and set the policies on them. And in this case, the default policy comes up with, it says, and again, I know it's kind of hard to read, and I apologize. I can't laser point on two sides at the same time because I'm not Neo. But it says effect allow, action, get, and list. So it allows you to read out of my S3 bucket. And the resource is everything. Now what you want to go through if you're actually doing this yourself is you want to isolate this just to your security bucket. And that's what I did. So I have a security bucket called CloudSec. That's where the credentials for all the stuff I'm about to demo for just the Chef demos are stored. And again, in a dynamic enterprise class environment, you can have lots and lots of these things. And you can segregate out all of those different credentials as part of that. And I should probably check my time here at some point. So good, we're on time here. And then you set that IAM role, and then you paste your initialization script. Now those initialization scripts, I did this manually. If you actually have something set for auto scaling, you can automatically run scripts as part of your policies for auto scaling. So that's another thing that you as security professionals need to be aware of, is that when you look at the applications and the dynamic environments that your guys are building, you want to make sure you actually figure out the process for how that application, the infrastructure for that application is managed for things like auto scaling, and then you can inject the appropriate security policies into that process. So you're actually built into that process, you're not relying on something outside of it. Now, I have a preset Chef server. I showed you a little bit of that. It's in its own little security group. I had all the other security groups and Chef credential kinds of things that were all set up. Chef is really, really cool. So it's one of a couple of different configuration management platforms. Puppet and Chef are the two biggest ones. They're pretty similar. Puppet is a little bit more user-friendly, I think, in some ways. Chef relies a lot more on Ruby coding. Anybody using it out here? Yeah. So, I mean, you got to be careful. There's dependency issues. You got to code things in the right order when you're using Chef. But because it is built on Ruby, it's really powerful. And for the stuff that we're trying to do, I really like it because I don't code for a living, and then I only have to learn one language to actually make all my stuff work. So you can get it over at ops code. And the idea is policy. It's actually code as policies. I probably wrote that backwards. And what that means is that your Chef recipes and stuff are actually Ruby code. And your cookbooks. So you have this concept of a server, which is where manages everything, a workstation, which is actually where you work to manage all the stuff on your server. And then you have nodes. Nodes are individual systems. Nodes can have attributes. This is really cool because you can apply attributes to nodes and then make really complex policy decisions. So you can create like a PCI attribute or a security sensitive attribute, and then any node with that attribute has to run the PCI or the security sensitive policies that you set, which are going to be Ruby code, which means it can become very complex. And the way that code is pulled together is in something called a recipe, and recipes build up into a cookbook. And so what you do is you say, I want to run, and I'll show you some of the cookbooks later because we use them as part of this demo. I want to run my mod security cookbook, and then here's all my configuration stuff for it, and then I apply that to anything that is a web server with the web server role. Or the web server attribute, however you'd probably use a role for that. And then bam, I instantly have now pushed out mod security rule set to all of my web servers in my environment. All that info is kept in a repository, and you can have different environments, test, production, development, and then Knife is the command line tool that you use it. And so I talked about you have that temporary certificate that's used for that initial bootstrapping process, but then every node in your environment has its own client certificate. Those are not reused within your environment. And those certificates are to secure all of the communications around your environment. So it's a pretty good by getting down to these per client certificates. And you can even divide up into different organizations, and Chef has some pretty good identity management infrastructure in itself. And so what I did in our script, which is, here's what I showed you when I actually pulled out the session, is I went ahead and I actually assigned that initial base rollout to all of my instances that are automatically running. And again, I showed manual pasting of the script, but that can be done completely. And the run list for that is what are the policies that are going to run. Again, demo land, so I kept it really simple. I'm setting the base, I'm running this Chef client piece, and what that's going to do is set it up as a service. So every one of those nodes is automatically every 30 minutes by default going to connect back to my Chef server and check for new policies. And then this delete validator, because we might as well delete that temporary credential off of our system. So just a couple of basic security things. So That's me blabbing because, like any demo running in the cloud, you never know how long things are going to take. And let's take a quick look at our instances here. I'll do a full page refresh because the Amazon web interface is weird. And while I'm waiting for that one to actually decide if it's going to work, no, I'm connected in. Gotta love the network here. Let's see what's going on my server. All right, so Chef's responsive. So one of the things is it takes a little while for all of that to run. So you'll see my instances running and getting up to speed before they actually show up in the Chef server. So depending on how quickly this one goes, oh, look at that. So we now have all of these things managed within my environment. And if I click on any one of them, you actually get a sense of what's going on here. So the run list, we ran the base. Sorry, it wasn't cookbooks. I ran a bunch of recipes for the Chef client and to delete that validation key. So that's already run on all of these right now. So they're all going to check in 30 minutes. They're all going to delete that validation key. And this gives you a sense of the power of the kinds of things that you can pull out. You can literally look at all of your block devices. So anything in /dev that appears in your environment, you can get it from the Chef management interface. We can look at the Chef client log files, figure out where all of that stuff is, how all of the Chef stuff is configured. Hey, what kind of a CPU are we running here? And what are the characteristics of our CPU? So I guess that's what I'm running on in Amazon, unless they fake that out. File system stuff, all of those things. You can actually also manage users and groups, so you can pre-create users, send their security credentials over there and handle all of that. And then you'll notice roles here, and I assign my base role. So that base role is really the hook, because once I get that base role, that's what sets all of this up for automation. Otherwise, it's only going to be manual in terms of the management onto that. So I realize it's almost anticlimactic for me to show you this. So let's take a moment and talk about what we just did. I ran an instance. That instance automatically pre-configured itself through a series of security credentials that pulled out of a secure repository and registered itself with my management server without me doing anything. I inserted that one script, fully automated process. I have full management of everything in my environment. Now, the one issue with that is well, that's fine, Rich, but how do I know that the admins ran that script? How do I know where things are in my environment? And that's where we start actually getting into the software-defined security stuff itself and the concept of security squirrel. So we're going to use APIs. So Amazon has an API, Chef has an API. And with APIs, we can actually program security to respond to events or proactively assess our environment in a very dynamic way, pulling all the information, all the details that I've shown you before. So we control the infrastructure itself, not just the security surrounding it. You can shut down machines, you can pause machines, you can fundamentally control all that infrastructure. Now, I showed you a lot of the Amazon stuff and I talked about those examples, but by hooking into Chef, we can literally force changes into running servers. Well, let us say having to manually log into those things. And we can do it on a massive scale by using policies. And so these APIs also allow us to integrate multiple tools and bridge. So in the security industry, if you buy security tools without APIs, tell your vendors they suck, because then you can't integrate it into this world. And that's where I came up with Security Squirrel. So it's a really simple proof of concept, which is designed to integrate Chef and EC2 using APIs in Ruby. It's easily expandable for you to do more stuff than what I'm going to demonstrate here today. And it identifies EC2 instances that are not managed by Chef. So that's basically the core thing here, is to find something hiding in my environment. And so the components that I use to build this is the AWS SDK for Ruby, Ridley, which is the SDK to allow Ruby access to the Chef API. I discovered some interesting bugs in Ridley as I was making this work that I still need to get around to reporting because it didn't behave as it was supposed to, and that ruined another weekend. And it saves us the time, by the way, using these APIs. All of this stuff is managed by REST APIs directly, but the SDKs just take a lot of that complexity out for you. And then we used Ruby to pull this stuff together. So let me go ahead and show the code here. And I have to make a slight change and pull it from the blog, because otherwise you would actually see my security credentials that are embedded in this, because I didn't set them up as temporary credentials. So let me just do this to make it more readable. and set this for Ruby so we get the color coding. All right, so basically we just include the Ruby gems we need, which is the SDK and Ridley for Chef. And it's really, really super simple. So we set our configuration stuff. That's the hard-coded stuff I don't want to end up on the video here. Then we set up an EC2 class, which you need for the Ruby stuff to access it. And then Amazon has this cool feature, cool function they added called Memoize, which just helps you pull down data out of Amazon and parse it more easily. So EC2 instances map, we're pulling the private DNS name of all of our instances. Really, I would want to use IP address. The reason I can't is because Ridley has a bug, and I can't get IP addresses out of Chef right now. So that'll be fixed at some point. But fortunately, the private DNS name, the way I configured everything, will match across EC2 and across Chef. So that's pull that information. Then I have to establish my Ridley connection. And then I pull all of my Ridley nodes, or I'm sorry, all of my Chef nodes using Ridley, and I put those into another array. The code that's the magic, I don't know, it's not magic, I think it's cool, is basically 3 lines. I pulled all that information down, and all I'm doing is a couple of things. It says instances each do, so for every instance in Amazon each do, EC2, tell me if it is managed in Chef, and then go ahead and print that out. So let's see what that looks like when I run it. Is that readable at all? All right. I taught for 4 days before, and we had a really bad projector in our room. Oops, okay. So I need to get the URL for where this code is running. I can't run it on my local system because I'm running let's say a version of an operating system that's considered beta. And as a result, Ruby doesn't work properly. All right, so I'm logging into the instance where I've got this thing running. Okay. And then I'm going to go ahead and run the script. All right, so basically what I've just done is you can see that in my environment, all of these instances are currently managed by Chef, and those instances at the bottom are not managed by Chef. And that's pretty much the, now think about for a second, how would you do this in your traditional environment? How would you find in our regular infrastructure every single running machine and figure out if it's managed by our configuration management system? What? Oh, you got to scan the fuck out of it, yeah, and good luck finding everything. I mean, that's all we have is our scanning tools. Now it's an API call. And with one API call, one simple script, I just demonstrate how to do something that is not only nearly impossible, but because all of this stuff is managed by Chef, then I can pull out all of the Chef policies. Would that make your auditor happy? Nothing makes your auditor happy. That was a trick question. All right, so once we've got all of this piece together in there, what else could we do? That was really simple. So suppose though that I have all these unmanaged things. Well, I showed you a lot of the different variables and stuff you can pull out. You can find out who the owner of that server is because you know who launched it in Amazon automatically. You could quarantine it on the network. You could transfer management of that to the Amazon, to the security team. You could snapshot it and shut it down, back it up. You could do almost anything you want. You can even bootstrap it into Chef once you find it, if you have the SSH key associated with it. And by the way, that SSH key, whatever SSH key is associated with every instance in your environment, is just one of the metadata pieces that Amazon gives you in that situation. Or you could automatically kick off vulnerability assessments. So everything I've showed you today, again, is pretty basic, and I really appreciate you guys sticking with me here because I know it was a little rough around the edges in a couple of spots. But I'm just like incredibly jazzed about what we're now able to do from a security perspective. This is the most exciting time to me personally in security since the first time I learned I could beat somebody up and not go to jail. And I used to do physical security. I didn't enjoy it. It was a job. You know, you had to. Nobody's laughing. Crap. Apparently I should go join the NSA. Or the TSA. The TSA. Okay. No, I don't like touching people. So back to the actual presentation. We now have this incredible ability to control our environment and do things we just couldn't do before. It doesn't solve all of our security problems. In some cases, it creates new security problems. If an attacker gets to our cloud management plane, they can literally delete your entire data center with 2 to 3 lines of code. And those are things you have to worry about. And how to defend all of that stuff is the kind of stuff we try and teach in the classes and when I'm out there working with people. But I love this, and hopefully you guys found it a little bit interesting. And I've got a couple of seconds left if there's any. Oh, I've got 10 minutes left. So, what questions do you guys have? Anything? Somebody's pointing. Oh, there's microphones. Yes, sir. I'll repeat the questions for the video.
You mentioned the cloud management plane. Have you looked at securing credentials and securing access to that management? It seems like Amazon used to do a bunch of clear text threads and says like all of these.
Yeah, so the question is how do you actually secure the management plane itself? I have looked at that, and there's a few different options that are out there today. And it wasn't this presentation, but I may actually be writing a white paper on that. So with Amazon in particular, you get those access keys and secret keys. There's a lot of static credentials that are involved. There's a couple of things you can do. Obviously, you can add multi-factor authentication. But another option is there's a new group of vendors coming out that are building proxies. I don't want to promote it because I'm not here to promote vendors or anything along those lines, but you can bug me later. I'll tell you personally. But basically what they do is you don't give your developers actual Amazon credentials. You give them credentials for that proxy. Their calls go through that proxy, and then that proxy has the actual Amazon credentials that connect into the environment. And some of those tools can actually enforce another layer of security policies at that proxy level. So if you screw something up with your Amazon IAM, and you can get really granular in managing those credentials for your admins, but at some point you do have admins that need some pretty deep access. You can isolate to different test and development environments. You can actually have per object. You can have tagging. So there's a new thing that was announced 2 weeks ago or within the last 2 weeks about how you can tag an instance and then use that to actually throw a set of IAM policies on it, which I don't have time to get into. So you can do all of those sorts of things. But I think we are probably moving to the world where, from a management perspective as security, we're going to have to start funneling all that stuff through proxies and be able to add that additional security intelligence to that. So you can bug me later. I can tell you who the vendors are. It's still really early days for a lot of those, though. And to be honest, it's only a moderately sized. It's a pretty small market. Any other questions? All right. Thanks a ton. I really appreciate your time.